Very good evening, everyone. Today's topic, yeah, today's topic is on optimization concepts, tools, and techniques of analysis. What is basically optimization?
Effective utilization.
Very good. It is a continuous process in any form or an industry or a business or entrepreneurship where in order to attain the highest performance or highest profits or in order to attain highest goals, reach aim highest goals, you need to optimize certain inputs. And given all the challenges, how best you can utilize them is all about the process of optimization. And few economists, if you look at the definitions they have given, optimization is as an process. It's like, a methodology which is all about a step-by-step process in making a decision partially or fully. At times, it is a mathematical procedure which in which is accompanied by a function, a mathematical function, which is applied in order to optimize the various inputs and best effectively utilize the available inputs and make the best out of it. Optimization is also referred as finding an alternative in the most effective. When a firm has, say, suppose you are a firm trying to fetch some raw material from a particular source, and that source is got some, is fixed some prices. Accordingly, you also check out with the other sources through which you can get the same kind of raw material, including logistics, service charges, etc. If your plan A is better than plan B in attaining the goal of the firm, then you choose plan, the B, which is giving you more profits. So buying a raw material from plan A is an optimum solution, or buying a raw material from plan B. At times, it is also seen that though it is costly buying from particular source, because of some other factors of production, you tend to buy it, though it is costly from product, say plan B, you end up buying from plan B just because of the final goal that you are looking for to attain. So that way, optimization is considered to be a process in which wherein an industry, a firm, a company continuously attempts to maintain a very smart, decisions in achieving the best results given the various challenges which they usually face, by trying to maximize their factors of production and minimize the minimize certain costs which can be otherwise ignored or avoided. Okay. The concept of optimization has been discussed in under various topics like the decision variable, objective function, feasible set. As you have understood that optimization is a process, it's a step-by-step process. It is not, in a one go you will attain everything. No, it should include variables like factors of production, which tends to play a vital role in reaching the desired objective of that particular unit. Next, second focus is on the objective function. And this objective function is mostly found to be in mathematical, it's like a mathematical relationship between the above variables and some other variables which out of which some are to be maximized and some are to be minimized. In that way, the objective function is developed. In order to do so, profits are another sub criteria to be looked at. And the cost, the amount of labor, machine time, raw material, etc., followed by consumer satisfaction level is quantified, and the commodities for which they, the quantity, the commodities which they are looking for, are in order to buy. All these put together forms a mathematical equation which in which you see the profits and the consumer satisfaction are to be maximized, whereas the cost of labor, machine, etc. are to be minimized. So this way we try to develop a objective function for a firm. And this is being utilized by the economist in deciding up the targeting, giving a target for, fixing prices, understanding the status of the labor, land, time, etc. Also, it gives an understanding of about how a consumer is satisfied or not. If not, then what measures can be taken up in order to make them satisfied. So these kind of strategic decision making is dependent on these objective functions. And then lastly, optimization concept is all about a feasible set. A feasible set here is sometimes described by one or more inequalities. Sometimes, it defines a set of various alternative choices which are available for variables. Yes, it is defined by one or more functions also. At times, mathematical equations that we're talking about in the second objective, more than one, equations can be developed. And for instance, those all can be checked, and the better option of which gives a better results that can be adopted by the firm. So that way, an optimization concept would probably function. Okay. And if you look at the a feasible set, the inequalities are defined as a Q. Okay. And this Q is also known that in a given consumption period, a consumer's expenditure, that means spending power, should not exceed his income. Hence, it is said that the feasible set should be given by P and Q, P1 and Q1 plus P1, uh, P2 and Q2, which should be less than or equal to M, where M is the money of the income, basically income of the consumer. It should be always any product that you buy, the purchasing power of any individual should be less than or equal to the income that they are able to earn. Okay. Now see, constraint and optimization. Constraints are all those limited resources which are handled by the firms in order to, make a proper, maximize the profits and attain the desired goal. That's all about optimizing the available resources in a best possible way by changing the variables by shifting the variables from 1 to or any number, and thereby deriving the results out of it. Alternative choices, alternative mathematical expressions are developed, and they are being uh, used for the purpose of deriving the results. And based on the results that are obtained, the best out of those results is being chosen by the firm in order to adopt. And the strategic decision making is totally based on those lines, the results of the mathematical expectations. Okay. And so constraints are here referred to all those variables which have got certain restrictions, or raw materials which are limited, resources which are doubtful, etc., falls under constraints. Certain things which are not available abundantly, they're limited in resources. So how do you manage them is all about optimization. And it's not about just managing, it is about managing at the same time, making a wise decision so as to maximize the profit. Okay, so that way, constraint optimization is studied. So in many situations, the firm happens to come across this kind of situation. And if you look at in the real world, there is, nothing which is available at free of cost, and and at the same time without any limitations or challenges. There are things available abundantly in the market. You can, provided you have money, provided you have place to store them. So that kind of challenges, probably timely receiving the material is another challenge. So that way there are many challenges which are faced by the firms in order to, uh, though they may be good enough, sound enough to buy the raw material. If you talk about raw material abundantly from various sources, but there may be other constraints, like the raw material may not be effectively utilized. There may be constraints on storing them. There may be constraints on the price of those raw material, because the prices of raw material keeps fluctuating. Today the rate may differ, and tomorrow they may either increase or decrease. So that way there are so many challenges which are associated. So taking into consideration all these constraints and then drafting the optimum solution is all about constraint optimization. Okay. So here there is a technique in order to adopt by the firm, which is popularly referred as Euler-Lagrange multiplier technique. This method is combined with objective function and the constraint, which is, limited with the firm, is given in one expression, which is referred as Lagrange expression. This expression, when is used by the firm, it tries to maximize the challenges and minimize the problem. See, there is no one-stop solution for all the problem, or a problem can be rooted out. It is just that in this complete subject of managerial economics, you happen to learn only about how you can minimize the risk, how you can maximize the profit and minimize the challenges. In what way? In the best possible way. And that is what we are here referring as optimization. Okay, so understanding all these techniques is given with the help of an example here. All of you, if you have a pen and book, please do take up and look at this maximizing function. And yes, maximizing y is equals to x square plus 8x plus 22. This is subject to x which is less than or equal to 2. This function is single and independent variable. And the objective function, say, suppose y is equals to minus x square plus 8x plus 22. It is plotted in the, diagram in the, yes, it is plotted in the diagram this way. And you can see here, you need to substitute the value from 1 to 10 and derive the value of y, after which start plotting it on the graph by making the x-axis and y-axis, and you will be getting this kind of plotting, which here this is x-axis and this is y-axis. So start plotting it from 1, 2, 3, 4. Here you need to substitute in place of x square. When x is 1, what is the value of y? When x is 2, what is the value of y? That way, try to derive all the values by computing the substituting x value and computing y value. Followed by draw this figure, and a small here objective function is expressed, and these all are maximized at 36. If you look at where x is equals to 4. So if you look at here, where x is equals to 4, it is maximized here. Okay. And those who are from mathematical background can go for derivatives, and derivative of y by derivative of x. And you can also solve using the derivatives if you are comfortable. Otherwise, you can skip and just do the mathematical expressions as it is given. Okay. So this is with single variable. This is with single variable. And in next, you will see two independent variables. Constraint with the two independent. Now, in this case here, the variables which are used in order in production process are x and y, and these x and y are limited in resources, says constraint, what we are calling them to be. They're constrained, and so we are using them. So here is the equation: z is equals to, and subject to x plus y is equals to 56. So that way you're going to solve this equation. A very simple mathematical calculation of derivatives here. Again, a basic fundamental applications of dy by dx can be easily done. If you all can just simply do this calculation. Just take your pen and papers and do this calculation. look at this question, demand function for P is equals to 45 minus 0.5 Q, and the average cost function is AC is average cost. AC here denotes average cost, which is Q square minus 8Q plus 57 plus Z by Q. And you're asked to calculate the output Q, where the total revenue is maximized and profits are maximized. So firstly, total revenue, if you look at the demand function is given, which is P is equals to 45 minus 0.5 Q, and the total revenue will be, total revenue here it's denoted as TR. So in this case, PQ, that means the demand function into quantity is equals to demand function as it is given. We are taking the same one. Okay. And the demand function here is 45 minus 0.5 Q into Q. Product of into multiplied with Q, which is giving us 45 minus 0.5 Q square. This is the TR, total revenue. Okay. Now, you need to go adopt derivatives and set it for 0 in order to solve this. So here we are using the derivatives, that is dr by dq. Okay, which is equals to 45 minus 0.5 q square. Now q square here, square, right? 2 will come down in the form of product. Okay, anything to the power of, if it is a square, derivative of a square will become 2a, 2 minus 1. So that way it is 45 minus 2 into 0.5 q, which is equals to 45 minus 2 into 0.5 is 1, and 45 minus q is equals to 0, or q is equals to 45. Now the second order, that is d square of r, derivative square of r divided by dqr is equals to this 45 minus q it is. So if there is no power, we consider it to be 1. So here comes minus 1 as in answer for this second order condition. Now, which is negative actually. Now, because of this negative sign, the before 1, this is total revenue is maximized when the output produced is 45. So if we take the profit function is denoted as here pi, and TR minus TA, that is total revenue minus total cost is profit is what we get. So TC, total cost, we need to calculate, compute. So this total cost is nothing but average cost is to be multiplied by Q, and average cost is here given in the function, in the question, that is q square 8q plus 57 plus 2 by q into q, and total revenue curve is given as 45 minus 0.5 q into q. Now you solve for this, multiply it with q square into q minus 8q square plus 57q plus 2. This is equals to 2 by q it is here. So 2 by q into q is 2 only. This is equals to 45 into q, 45q, 0.5q into q, 0.5q square. So here is the equation of total cost, which is 45q minus 0.5q. Now, when we submit TR and TC in the profit function, this is our profit function. So profit function is equals to 45q, that is TR equation. What is TR equation? TC and TR. TC and TR. So when we are substituting this and simplifying TR minus TC, you are going to get this value of pi, that is profit. And All right. So here we get the value profit as 9. Now, when q is equals to 1, we have a function. Substituting this value into this equation, we get 9 as positive. So, when here we conclude that q is equals to 4, quantity is equals to 4 is the profit maximizing. That means 4 quantity is the a point where the profits can be maximized, and the level of profit is 6. After substituting q is equals to 4 in the profit function, you will be getting 6. Profit function and total average cost function, we have computed the value of q and the profits. Okay, at this point, we consider the optimum utilization of resources. Further, we have optimization function. Again, f of derivatives are used here. So all those who are equipped with the derivatives can easily work out. And those who don't, please don't get worried. You just have to simply understand the fundamentals, 2 to 3 calculations of derivatives, where dy by dx is equals to, suppose a square you have. This a square here will become when it is when we compute for derivatives, a square will become 2a to the power of 2 minus 1. That means 2a to the power of 1 or 2a only. Right? Suppose if it is 4a square, that means 2 into 4a 2 minus 1. So 2 4 is 8. 8a to the power of 1 or 8a. So that way, very simple it is, not much in details of derivatives. A very fundamental calculation is required. I think you can simply, do it on your own. Just start doing it. Practice 2 to 3 problems. You will understand the fundamentals. Okay. Next, we move on to tools and techniques of optimization. Now, in order to do the computations, there are certain methods which are adopted. Out of those methods, the popular ones which are adopted by in order to calculate the optimizing point, the firms most popularly follow linear programming and gaming theory, game theory, where in game theory, if you look at maxima and minima points are identified, are computed, and thereby saddle point where there is no, like a break-even point, you call it as your break-even point. Okay, in gaming theory, we call it as a saddle point where, there is no profit, no loss. Okay, by the, parties, yeah, both the players. So game is all about identifying the various variables and fixing those variables in the form of mathematical equation, and thereby solving it with the help of game theory. We also have dominance theory in game theory, which will talk more about a particular input which has got more dominance as compared to other variables. So that in that case, there may be impact on the, not on the equation, but on the results. So that way, see here, when we are working out all this on paper, maybe linear programming, game theory, or any other technique that the firm is, adopting, all these are put on paper and the results are discussed. After discussing these results, the best optimum result which is giving, they adopt the that particular mathematical expression, and they continue to adopt that expression for making their strategic decisions. So that way, linear programming is a tool where objective function maximizing and minimizing functions are derived, and accordingly, the linear programming is with the help of linear programming technique, these maximization, minimization of variable is done, and mathematical expression is developed, and then the available inputs or resources of the by the company are inserted in substituted in that equation, followed by the results are derived. Similarly, in game theory also it is same. Okay. Game theory is all about players where one is losing and other one is gaining. And here also the available inputs are identified, and the output, that is the objective function, is put in place in order to develop a mathematical equation. Game theory, if you know, well and good. Otherwise, it is more or less like, appearance is like in matrices. Matrices, if you all can recollect, 2, 3, 4, 5, like this, we write no in brackets expression. So if you have 2, 3, 4, 5, and 2, 1, like this, you end up writing. So that way, game theory is developed. And in this game theory, one is a loser and one is a winner. And while being loser also, the game theory enables the form to understand and utilize the resources available optimally. That is the best part of game theory, where you can just simply understand that losing, when a game is played, any of the any one of the player is definitely going to win and the other is going to definitely lose it. That is natural. But losing, if sideline it, how much hit you are, that should be computed. So how much badly you are hit, okay, how much you can safeguard yourself, and what are the various tricks and tips that will avoid you to take it to the last level in the losing position. So that way try to overcome by adopting this game theory. Firms tries to understand the resources, though okay, you are are not making it good, and you are almost close to losing to your competitor, fine, but in that scenario as well, how much better, best you can play to give stiff competition, at the same time minimize your risk and play a safe game. That is all about game theory. Okay. And then we have input output model. This model is like, almost same like a matrix in algebra, where understanding the inputs and output relationship is essential. And the nature, the technological relationship which exists between these are of very significance here. Okay, so the input and output, what are the raw materials and how the quantity is being, uh, uh, you know, uh, uh, put for sale, and how the sales are happening. All this is taken into consideration, and a model is developed in the form of matrix in algebra, and thereby it is solved. Of course, it has got certain criticism. Is being criticized on the grounds that it is only focused on input and output, thereby excluding various other factors which directly may not be, but indirectly they have influence on the output of the company, of the firm. And those it can be about technology, it can be about the constraints that we have discussed. So there can be many, and those are said to be here, sidelined. So that way, input-output model is also one of the model. But if you look at linear programming and gaming theory are the most popular ones which are utilized. Of course, input-output model is also been adopted by many firms in order to better understand the challenges that they are facing. And this is basically uh, developed, mathematical equations are developed, in the form of a matrix that we usually solve in algebra. And the same principles are followed as in the case of matrix here. All right. So with this optimization unit is done. I expect you all to work out the examples here which are given. If these two examples, if you work out with, great interest, that would definitely help you in not only solving your assignments, but also doing well in your examination. Besides, you are given one more problem here in the long answer questions, wherein the demand function is given, average cost is given. You're asked to compute the level of outputs. So same question, example, illustration is available. This you all can take up and solve it for yourself. It is almost in the same lines. Only the numbers have changed in the equations. You can do it. Okay. And other than this, there are textbooks on by Adhikari, Peterson and Lewis. So these textbooks can be borrowed, and if you are in a position to refer more and more textbook and compute, you're most welcome. I can give you a list of textbooks besides this suggested reading. Yesterday's class also I referred some. So for this optimization, Peterson and Lewis textbook, many illustrations are there, and exercise and questions are available, which you all can simply practice it for gaining confidence in the subject. And I do not get scared of derivatives, etc. for all those who are from non-mathematics. Okay, mathematics background in intermediate will have no issues, I assure you. But those with, without mathematics, also please do not. I assure you, one or two problems, fundamental, simple calculations that I showed in today's class, derivative of dy of dx is equals to, if you simply one or two equations and one or two at the most rules, if you principles to solve derivatives, if you are able to do, I am sure you will definitely be able to do all this kind of problems. All right. So if you have any query, please raise up your queries in the chat box. With this, the block 1 is done, and tomorrow's class will be taking up demand and supply, the very interesting, block, which deals with how demand and how the supply is managed, demand and supply analysis by the firm. So production houses keeps manufacturing, but on a continuous basis. Given the targets, they are only to fulfill the targets and make enough sufficient products. But are all those products being sold in the market? If yes, then the profit maximization is attained. But if no, then what? Okay, there comes a need for understanding the demand and supply. How much is demanded and how much is to be supplied. And in order to have control and influence on the prices of certain commodities, demand and supply are being, firms purposefully designed, intervene in supplying the amount of goods and services into the market. So all this we are going to learn in the coming up next unit. Meanwhile, if you have any queries for today's class, anyone, please raise up in the chat box and do work out the problems for today. Tomorrow's class will be doing demand and supply. Any queries, anyone, please do raise up. Otherwise, you are free to leave up for the next class. If you have any queries, please remain, or else we can stop the class here.